For the invitation, John. It's a pleasure for me to meet with all of you. This is a great panel. I'm from Panama. My name is Dimas Kiel. Vaccination therapy for indolent lymphoma. Where would they it? Okay, interesting question. The vaccine therapy for B-cell lymphoma is the next generation strategies. The follicular, for many reasons, follicular lymphoma is the most common low-grade non-Hodgkin lymphoma. It's 22% of the all of cases in Hodgkin lymphoma. However, advanced disease is presented 85% of all of patients at this time of diagnosis. And inclusion with the combination chemotherapy with anti-monoclonal antibody, uh, this kind of therapy to not be cured the patient. Several lines of evidence suggest that the follicular lymphoma may be the high sensitivity of immunotherapy. The first one is spontaneous remission lasting longer than 1 year have been observed in up to 23% of the patient. The second, the administration of single agent rituximab in previously untreated patients with follicular lymphoma has resulted in clinical response in more than 70% of the patients. The third, the survival of patients with follicular lymphoma appears to correlate with the gene expression signals and infiltration non-malignant immune cell in the tumor. Active immunotherapy with cancer-based vaccination may be potential induce a polyclonal, humoral, and cellular immune response with immunologic memory and minimize the emergence of tumor escape variant. The vaccination strategy targeting new Hodgkin lymphoma has a largely focus in using a tumor immunoglobulin molecular express on the surface of the malignancy B cell. The first, the varying the variable region on the heavy and light chains of the tumor immunoglobulin contain unique determinant on not ideotype serves as a tumor-specific antigen. The second one, the tumor immunoglobulin appears to be essential for tumor cell survival. And the third one, the ideotype vaccination can potentially induce a polyclonal antibody and reduce the appearance of immune escape cell tumor. That is a fourth uh, through hybridome cells uh, purified ideotype conjugate in immunostimulate cells prevent to the, the biopsy. The phase one clinical trial in this kind of vaccination was for the Dr. Kent Watt working with a laboratory at Stanford in follicular lymphoma, which is a pilot study designed to determine where it was possible to immunize again with the ideotype portion of this of the protein. The patient with follicular lymphoma in clinical remission after chemotherapy immunized with subcutaneous injection autologous peripheral tumor derived immunoglobulin conjugate with KLH. Okay. In this patient, 41 patients was treated with this pilot study. 41 demonstrate a specific anti-idiotype antibody. Curiously, there are interesting difference between in the patient with the first remission in and demonstrate immunologic response to this vaccination respect to the patient with the first remission and did not get uh, immunologic response with this kind of vaccination as correlate with the overall survivor. Okay, this first study, first phase one study, opened the door for the second and third clinical phase in this kind of vaccination. The phase two, sorry, monitoring of the patient with minimal residual disease showed that 8 of 11 patients with a PCR positive for translocation 14-18 chromosome breakpoint converted to PCR negative in their blood immediately after completion vaccination, with the molecular transmission for a median in 18 months. This data provide evidence for antitumor effect in the idiotype vaccination view. The phase 2 clinical trial idiotype vaccination, additional clinical trial using idiotype with combination with GM-CSF or pulse of dendritic cell vaccination. There are information to demonstrate that 35 patients with follicular lymphoma with dendritic cell pulse with tumor-derived idiotype proteins, 70% remain without tumor progression at a median of 43 months after chemo. There are information to B-cell depletion, evaluate the patient with the B-cell depletion induced by rituximab has a response to. One of this evaluation was the combination with the chemo and patient with the treatment was autologous tumor-derived idiotype in combination with GM-CSF vaccination following to induction chemo. Despite rituximab administration, antibody response again, the carry molecular KLH and idiotype were detected in 17 out of 23 patients and 70 out of 23 patients evaluated, respectively. The next generation of lymphoma vaccination, maybe it's a DNA vaccination, another is a membrane proteoliposomal vaccination. There are different kind of material for this kind of vaccination. The production time is different respect to how do you get the antigen. The target was different, and there are the different phases study. This is only in phase 3, idiotype protein KLA. Dendritic cells is a really important tool in this vaccination response. Have the predominant growth a differential factor L33L. The recombinant for the protein represents complete phase 1 testing in healthy volunteers. Preclinical study have showed that injection with growth factor directed into the tumor with the number and intratumoral dendritic cell can be significantly increased. This was demonstrated in several studies. One of these studies, this one, and it's an in situ vaccination approach consistent on low dose of radiotherapy and administrate injection and immune cell stimulating TLR. This is a tool-like receptor agonist, radiotherapy, low dose, intramuscular injection, and the vaccination in this intratumor site, the dendritic cell instructed the priming tumor anti-tumor T cell, which then travel through the rest of the body to eliminate their tumor target. There are many studies in phase 3 to demonstrate the vaccination in specific tumor-derived antigen is the first remission. In the first remission, improved the disease-free survival in follicular lymphoma. In conclusion, the debate over whether the immune system can treat cancer is done. The next decade, the question is how the best to modulate the immune system to recognize tumor, which tumor antigen are most affected, the role of checkpoint blockade, immune stimulation. If for respond this question, only enrolling of patient onto clinical trial will provide the answer. Thank you.
So thank you. And any question, John? It's always, especially with the follicular lymphoma, potentially the anti-IDs always seem like such a nice target because it's going to be just, for that tumor. I mean, it makes sense, but it's always been, really probably the immunosuppressive. You can actually, create the anti-IDs, but it's hard to make the whole immune cycle, as we are calling it now, go. I mean, is this something that in a checkpoint inhibitor would make sense to do this with it? Is that, you get the antigen stimulation, hopefully you'll get the T cell trafficking, and then you can actually take the brakes off within the tumor. But that's, I think, as you mentioned there, that to me seems like the natural next step in trying to do this, because otherwise it seems like, we get the stimulation, but then the intratumoral basically immunosuppression, the tumor protecting itself is stopping it from occurring. And I don't know if anybody, um, any thoughts on that, but that it seems like it really, these things are set up naturally for the immune checkpoint inhibitors to add them.
So yes, I would say that that's true. One of the difficulties, though, is that obviously idiotype vaccines has had a very long run, and they have, other than relatively almost anecdotal settings, have really failed. And so I think you could certainly try that. However, they're very costly. One of the other issues is that as we move into checkpoints, it may not be necessary to actually vaccinate as well. I think there is clear evidence out there that there is, in fact, endogenous immunity against these tumors as well. That in like the study that was quoted up here from us, we looked at whether or not there was tumor-specific cytotoxic T cells prior to therapy, and the answer was yes. And those cases that had the highest rate of pre-vaccine cytotoxic T cells against their tumors were the ones that actually got the boost highest. And so it may be that checkpoint inhibitors alone may be useful. We're moving into CARs and other therapies. So it may be that the vaccine field is too little, too late, but I certainly think that it's something that makes sense.
Yeah, I think it's the same things happening with the CAR T cells as was mentioned. So um, to combine also the checkpoint inhibitors or any immunostimulants like lenalidomide also. Um, so that's the idea, but then probably there is the immune system. So when you stimulate the immune system, they can recognize the tumor without it.
And,
Really, your vaccination very likely. So
and I think your point, I think is exactly right. There's always something, but the immune system is so powerful. It could basically, if it's out of control, the host dies within a day. That there's so many ways the body prevents, having autoimmunity, and the tumors just exploit that. That again, I think checkpoints themselves may be good, but they're probably not going to be enough in these. And I think even the early studies that it's going to be, I think we're going to have to look at a couple different steps in that cycle, be it, having the CAR Ts, which is, again, CAR Ts are almost, doing this in a better way, is making, the cells there. Though the vaccines, I mean, especially some of these that could potentially, there was a company that was creating these out of tobacco plants, which is actually, they can make you can make a ton of vaccines very quickly. There can be technologies with vaccines that can maybe make it a lot less expensive than the CAR Ts, unless you start getting some of the CAR Ts that may not, be patient specific, because that's just always going to have a pretty high cost to that care. So,
Well, I think that some of the criticisms that have been raised over the years, and I think something that Larry Kwok said, was that when you start to move into these recombinant methods of making them, you're losing some of the tertiary structure that's associated with making it in a mammalian system. So
And
That's one of the
yeah, and that was one
possible
of the things with the
downsides.
tobacco one is the question was, is it going to make it more immunogenic or less because it has a different glycosylation pattern than the mammalians have. So again, the thought when they were doing that was that it might actually make it more immunogenic. Now, we don't know because again, I think always on these vaccines is the break at the end was one of the things, and we never had really a good enough adjuvant. But you would see it. I mean, I remember a patient with low grade lymphoma who had always had a big mass on her head, and every time she would get a sinusitis, it'd just go away. And then she'd get better. I'd give her antibiotics, she'd feel better, then it'd start to grow. And you just know that there was this balance in the immune system with her that she lived many many years, but all she needed to do was get a sinus infection and her lymph nodes went away. So there is an immune sensitivity. It's just kind of getting that balance right.
I mean, the issue, the vaccines goes back so many years now, and it hasn't really taken off the ground as we maybe hoped years ago. So, I mean, if we start talking about CAR T and we talk about resources, I mean, there's something obviously that we have to consider. I mean, it's not something that could be not only the cost of it, but even the practicality of doing CAR T. I always think, I mean, if you look at the data with the bispecific monoclonal antibodies, which look in certain disease which are in certain disease extremely exciting, I think it's easier to give an antibody than to set up all a CAR T and spend 500,000 up front. So I think we have to be some degree of caution, particularly since cost issues come up repeatedly.
Yeah, well, we're going to talk about the CAR T-cells in a bit, but definitely the concept is the following. So all the vaccination studies like the CAR T-cells are very nice in principle. They made us understand that indeed the immune system can work, but probably then at the end it's always like a pill or an injection will be easier than to manufacture all this material, which takes time. It's really personalized, but then you cannot think as a product, off-shelf product.
So this, I really, Dr. Rodriguez, I liked your presentation. Especially the content of your presentation is very close to my heart. Dr. Kwok and Dr. Nilapu and I worked together for the past 10 years. So I know each of the publication, I know the good point, the bad point, and when Dr. Steven Schuster presented the phase 3 clinical trial that showed only failure-free survival, but no survival difference, that made the whole immunotherapy reach to the nadir. Is everybody thinks that immunotherapy is not going to work, and only about 5 years later, now immunotherapy is hot again. So the immunotherapy points are progressing, so that will bring another new time for the vaccine therapy. First of all, now we know that tumors are, in general, some of the tumors are immunogenic. For example, renal cell carcinoma, melanoma, and large cell and follicular lymphoma. Those lymphomas and all diseases sometimes go through spontaneous regression. So we think in large they are immunogenic. Immunogenic tumors are prone to immune modulation and therapy. But some of the other tumors, like lung cancer, pancreatic cancer, they ignore. They are not immunogenic. They are immune inert. So recently, there's this article about published in Lancet Oncology based on the clinical trial by Dr. Nilapu and us et al. We did the T cell subset score and found a 41 gene signature that can actually, within the follicular lymphoma, you can tell which tumor has higher score, therefore more immunogenic. It is going to be cured or good response with the immunotherapy. But within the follicular lymphoma, some of the T subset, the score is low, they are immune inert. And although they are follicular, but they belong to the immune inert, and they should be treated with other therapies other than immunotherapy. Immunotherapy is not created equal for every patient. It needs to be, yeah. So that's one point. The second point is that those days, the vaccine therapy has a new era. For example, Dr. Ron Levy and many other laboratories, they found that if you kill one tumor, and maybe sometimes the other tumors that was not attacked could regress. For example, You clinically you read it there's patient have 5-10 tumors. You read it one tumor, and the rest of tumor are gone. Why? Because you radiation, you kill the tumor release antigen, and you induce an immune response, and the immune response kill other tumors. So on top of that, they could put in checkpoint inhibitors, other therapies to make it higher. That's one point of progression in the vaccine business. The other thing is that using the same concept, Dr. Ron Levy has, their lab injected chemotherapy into one tumor, and they found the regression from other tumors in mice. This does not occur in lymphoma. I asked all my radiation oncologists, did you radiate one tumor and the rest tumor is gone? They never found it. But Dr. Levy's lab is having a clinical protocol. They inject the cytoxin in the tumor. They can enhance the vaccine to cure the other tumors. So my point is that the ideal type of vaccine is a laborious, time-consuming, extensive therapy. But if for it to work, it has to be combined with other immunomodalities. Thank you.